Alright, in this video I'll be solving my Stats 1 October-November 2024 guest paper. If you want to solve this before you see the solution, make sure to get a copy of the paper on my website. Otherwise, let's get into it. Number 1. A soccer player has 3 attempts to score a penalty. The random variable x denotes the number of penalties scored. The probability distribution table for x is shown below. Part A. Given that the expectation of x is equal to 0.85, find the value of p and the value of r. Alright, so we can use the formula for expectation. So we know that the formula for expectation of x is equal to the summation of x times p. So in this case, that would be 0 times 0.5 plus 1 times p plus 2 times r plus 3 times 0.1, and in this case we're saying this is equal to 0.85. So let's simplify. This here will cancel out. This becomes p plus 2r plus 0.3, and this is equal to 0.85. So p plus 2r is equal to 0.85 minus 0.3, which gives us 0.55. Now we can also create another equation in terms of p and r using the idea that the sum of the probabilities should add up to 1. So if we add up all the probabilities that we have over here, they should add up to 1. So that's 0.5 plus p plus r plus 0.1, and this is equal to 1. So we get p plus r plus 0.6 is equal to 1. P plus r is equal to 0.4. Let's make p subject of the formula. So p is 0.4 minus r. Now we've got two equations in terms of p and r. So we can simply solve them simultaneously to evaluate both p and r. So in our second equation, we made p the subject of the formula, so you can substitute p over here with 0.4 minus r. So 0.4 minus r plus 2r is equal to 0.55. So that's 0.4 plus r is equal to 0.55. So r is equal to 0.55 minus 0.4, which is 0.15, and so p is equal to 0.4 minus 0.15. P is equal to 0.25. So you can conclude that therefore p is 0.25 and r is 0.15. Part B. Find the numerical value of var of x. So the formula for var of x is equal to the summation of x squared p minus the expectation of x squared. We already know the expectation of x from part A. What we need to find is the summation of x squared p. So the summation of x squared p is equal to, so this is 0 squared times our first probability. What's our first probability? That's 0.5 times 0.5 plus 1 squared times p is 0.25, plus 2 squared times r is 0.15, plus 3 squared times 0.1. Let's punch this into the calculator. This is summation of x squared p. So that's 1 times 0.25 plus 2 squared times 0.15 plus 3 squared times 0.1, and this gives us 1.75. 1.75. So now let's substitute into the formula for variance. Var of x is equal to 1.75 minus our expectation, which is 0.85. So minus 0.85 squared. Var of x is equal to, let's punch that into the calculator, 1.75 minus 0.85 squared, and this gives us 1.03, and that's our final answer. Number 2. For his afternoon snack, Sam has either crisps, cookies, or fruit with probabilities 0.4, 0.35, and 0.25 respectively. When he has crisps, the probability that he has a soda is 0.5. When he has cookies, the probability that he has a soda is 0.3. When he has fruit, he never has a soda. Find the probability that Sam has cookies given that he does not have a soda. Alright, so let's start by creating a tree diagram to represent what's going on here. So we've got Sam having either crisps, cookies, or fruit, and this is with probabilities 0.4, 0.35, and 0.25. Alright, and we're told that when Sam has crisps, the probability of him having a soda is 0.5. So soda and not soda, that's 0.5, 0.5. And then when he has cookies, we've got soda and not soda, the probability of him having a soda is 0.3. So not having is 0.7. Then for fruits, they're saying he never has a soda, so that's 0, and this is 1. Alright, now they want us to find the probability that Sam has cookies given that he does not have a soda. So probability that Sam has cookies given that Sam does not have a soda. Alright, so that will be equal to the probability of Sam having cookies and not having a soda divided by the probability of Sam not having a soda. Alright, so let's start by finding the probability that Sam has cookies and does not have a soda. So the probability that Sam has cookies is 0.35, and when he has cookies, the probability of not having a soda is 0.7. 0.7. Alright, so let's punch that into the calculator. That is 0.35 multiplied by 0.7, and this gives us 0.245. 0.245. And now let's evaluate the probability of not having a soda at all. So the probability of not having a soda would be probability of, what's the first option? Crisps. Probability of having crisps and not having a soda, plus the probability of having cookies and not having a soda, plus the probability of having fruit and not having a soda. Right, so let's evaluate our 3 scenarios. So the first scenario is that he has crisps, that's 0.4, and after having crisps he does not have a soda, that's 0.5. So times 0.5, 0.5, and then we already evaluated the scenario of cookies and no soda, that's 0.245, so plus 0.245, and then the last scenario he has fruit, that's 0.25, but does not have a soda, that's 1, so times 1. Alright, Let's simplify. This gives us, we've got 0.4 times 0.5. That gives us 0.2 plus 0.245 plus 0.25. And so if we add everything together, that is 0.2 plus 0.245 plus 0.25, that gives us 0.695. 0.695. Now let's evaluate our conditional probability. The probability of Sam eating cookies, given that it does not have a soda, is equal to 0.245 over 0.695. So let's punch this into the calculator and see what we get. This is 0.245 divided by 0.695, and that gives us 49 over 139. 49 over 139, and that's our final answer. Number 3. The probability that a student passes a final exam is 0.7 on any given attempt. Part A. Arun keeps taking the exam until he passes. The random variable x denotes the number of attempts required for Arun to pass the exam. Part I. Find the probability that x is between 2 and 5 inclusive. Alright, so we're looking for the number of attempts until Arun passes the exam. So this tells us that this is a geometric progression, because he's going to attempt to take the exam until he gets his first success, until he gets his first pass. So x follows a geometrical distribution, and the probability of success is 0.7. And they want us to find the probability that x is between 2 and 5. So instead of evaluating x is 2, x is 3, x is 4, and x is 5, we can write this as the probability that x is less than or equal to 5 minus the probability that x is less than 2, which is the same as x is less than or equal to 1. And this allows us to use the formula probability that x is less than or equal to r is equal to 1 minus q to the power r. So in our case, this becomes 1 minus our q is the probability of failure. In this case, that's 0.3. And in this case, for x is less than or equal to 5, our r would be 5. And then we do the same here. That's 1 minus 0.3 to the power r. R in this case is 1. So we can just leave it like this. And let's punch that into the calculator. That's 1 minus 0.3 to the power of 5 minus 1 minus 0.3. And so this gives us 0.298. This gives us probability that x is between 2 and 5 is equal to 0.298. Alright, and part 2 says find the expectation of x. So the expectation of x is equal to 1 over our probability of success. What's our probability of success? That's 0.7. Let's punch this into the calculator to simplify it. 1 over 0.7, that is 10 over 7. So expectation of x is equal to 10 over 7, and that's our final answer. 5 students will each take the final exam tomorrow. Part B, find the probability that at least 3 of them will pass tomorrow. So this has actually changed to a binomial distribution. We can define our random variable y to be number of students that pass the exam. Number of students that pass final exam. We now have a fixed number of trials. In this case, we're dealing with 5 students. It's a binomial distribution, not normal. So 5 students, our n is 5, and our probability of success, as we're given in the stem of the question, is 0.7. And we want to find the probability that at least 3. So the probability that y is greater than or equal to 3. This is the probability that y equals 3, 4, 5. So let's evaluate that. That would be 5 choose 3 times the probability of success, which is 0.7 to the power 3 times q to the power 2 plus 5 choose 4 times 0.7 to the 4 times 0.3 plus 0.7 to the 5. Alright, so let's simplify this. We've got 5 choose 3 multiplied by 0.7 to the power 3 times 0.3 squared, and that gives us 0.3087 plus we've got 5 choose 4 times 0.7 to the power 4 times 0.3, and this gives us 0.3602. 0.3602. And then finally we've got our 0.7 to the power 5, and that is 0.1681. 0.1681. Let's add up all our probabilities. That's 0.3087 plus 0.3602 plus 0.1681, and this gives us 0.837. So we can conclude that the probability that y is greater than or equal to 3 is 0.837, and that's our final answer. 80 students will take their final exam next week. Part C. Use an approximation to find the probability that more than 50 of them will pass next week. Alright, so let's define our random variable. That's f is the random variable, number of students that pass final exam. Alright, and f follows a binomial distribution since we have a fixed number of trials, 80, and our probability of success is still 0.7. But they've told us to use an approximation, so that means we're going to use the normal approximation to the binomial distribution. So to do that, let's first evaluate NP. NP is 80 times is 0.7, so NP is equal to, let's punch that into the calculator, 80 times 0.7, that gives us 56. And then we also have to evaluate NPQ, which is 80 times 0.7 times 0.3. NPQ is equal to, let's punch that into the calculator, 80 times 0.7 times 0.3, and that gives us 16.8. 16.8. So if we're now moving this to a normal distribution, f follows a normal distribution with mean NP and variance NPQ. So f follows a normal distribution with mean 56 and variance 16.8. And we are supposed to find the probability that more than 50, so greater than 50, will pass next week. Alright, So this if is greater than 50 was defined under binomial conditions. So we actually have to apply continuity correction. So that means greater than 50. Remember, greater than 50 represents a number between, that's 49.5 and 50.5. So any number between 49.5 and 50.5 is technically 50 under continuous conditions. In this case, since our numbers must be greater than 50, we're going to start counting from 50.5 since we're going upwards. So this becomes 50.5. So that's what we're solving for, the probability that f is greater than 50.5. So let's standardize. Z is greater than 50.5 minus 56 over the square root of 16.8. And let's punch this into the calculator. The probability that Z is greater than, this is 50.5, this is 50.5 minus 56 divided by the square root of 16.8, and this gives us negative 1.342. Negative 1.342. So this is the same as phi of 1.342. And phi of 1.342 is equal to 0.910. And so therefore our final answer here is 0.910. Number 4. The times t minutes taken by 200 students to solve a puzzle are summarized in the following cumulative frequency table. Part A. Draw a cumulative frequency graph to illustrate the data. Okay, so our cumulative frequency will go on the y-axis. So this is cumulative frequency. And then we will have our times in minutes on the x-axis. Alright, and we need to figure out what scales we can use. So our cumulative frequency goes up to 200. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so we can go from 0 up to 200 moving in 20 unit intervals. So that's 40, that's 60, that's 80, that's 100, that's 120, 140, 160, 180, and then finally 200. Alright, and we do the same in the x-axis. It also looks like we've got 10 boxes and we're moving from 0 to 100. So this here is 0, this is 10, this is 20, 30, 40, 50, 60, 70, 80, 90, 100. Alright, now let's plot our upper bounds against their cumulative frequency. So we've got 20 and 16. Alright, so 20 would be here, and then we want 16. So 16 would be, we're moving in 2 units here, so 16 should be at this point over there. Alright, and then we need to plot our next set of points. So we've got 30 and 64, 30, 64. So 30, 64 would be here, and then we've got 40 and 141, 40 and 141. 40 is this line over here. We want 141. we are moving in 2-unit intervals, so 141 should be that point there. And then we've got 60 and 179, 60 and 179, this is 40, so there's 50, there's 60, and we want 179, which should be there. And then finally we want 100 and 200, which is the top corner. Yeah. Alright, so now we simply have to join the points and form an S-shaped curve. So let's see if we can do that. We're starting from 0, 0, and then something like this. Alright, and that is our cumulative frequency graph. Part B. 36% of the students take K minutes or longer to complete the puzzle. Use your graph to estimate the value of K. So if 36% of students take K minutes or longer, it must mean that 64% take less than K minutes. Less than K minutes. The reason we're reversing our question here is because it will be easier for us to work with the 64% rather than the 36%. So we want 64% of 200. Since we've got a total of 200 students, let's punch that into the calculator. That gives us 128 students. So now we're going to draw construction lines at 100 and at a cumulative frequency of 128. So let's just zoom in a little bit. So this will be 122, 124, 126, and then 128 is here. So let's draw construction lines up until we get to the curve. Alright, and now we start going downwards. Until we get to our value. Alright, so this here looks like it's 37. Yes, that's 37. Alright, so we can conclude that K, therefore K is equal to 37. So what this means is that 64% of students, which is the 128, take less than 37 minutes to complete the puzzle. And it means that 36% of students take 37 or more minutes to complete their puzzle. Part C. Calculate estimates of the mean and standard deviation of the time taken to complete the puzzle. Alright, for us to be able to find the mean and the standard deviation, we first need to find the midpoints and the frequency. So we need a table with midpoints and frequencies. Alright. How many classes do we have? We've got 2, 4, 5 classes. 5 classes, so 1, 2, 3, 4. Alright, and then let's complete our table. Obviously use a ruler. Alright, so let's start by finding our midpoints. So for the first class, it's running from 0 to 20. That means its midpoint would be 10. And then the second class is running from 20 up until 30. So that means its midpoint is 25. 25. The third class is running from 30 up until 40, so its midpoint is 35. The fourth class is running from 40 to 60, so midpoint is 50. And then our final class is running from 60 to 100, so the midpoint is 80. And then now we need the frequencies. So the frequency for the first class will be the 16. So that's 16. And then the frequency for the second class is 64 minus 16. So if we punch that into the calculator, 64 minus 16, we get 48. And then the third class, its frequency would be 141 minus 64. Let's punch that into the calculator. 141 minus 64, that gives us 77. So this is 77. And then the fourth class would be 179 minus 141. 179 minus 141, that gives us 38. And then the final class would be 200 minus 179, which is 21. Alright, so now that we have our midpoints and our frequencies, we can go ahead and find our mean. The formula for grouped mean is the summation of x times f divided by the summation of f. In this case, our midpoints are denoted by x and our frequency is denoted by f. So let's calculate our x bar. X bar is equal to, that's 10 times 16 plus 25 times 48 plus 35 times 77 plus 50 times 38 plus 80 times 21, and this is all over 200, because remember we're dealing with a total of 200 students. Alright, so let's simplify our numerator. That's 10 times 16 plus 25 times 48 plus 35 times 77 plus 50 times 38 plus 80 times 21, and this gives us 7,635, and this is being divided by 200, so x bar is equal to, let's punch that into the calculator, and we get 38.175. This is our mean. Now we need to find our standard deviation. The formula for standard deviation is equal to the square root of the summation of x squared f divided by the summation of f minus x bar squared. So let's start by finding the summation of x squared f. The summation of x squared f is equal to, it's basically the numerator of this expression, except for every instance of x we're squaring it. So that's 10 squared times 16 plus 25 squared times 48 plus 35 squared times 77 plus 50 squared times 38 plus 80 squared times 21. Let's punch that into the calculator. This is 10 squared times 16 plus 25 squared times 48 plus 35 squared times 77 plus 50 squared times 38 plus 80 squared times 21, and this gives us 355,325. Okay, so now we can substitute into the equation for standard deviation. Let's do it on the side. So sigma is equal to the square root of, that's 355,325 over the summation of f, which is 200, minus our mean squared. Our mean is 38.175, and this is squared, so sigma is equal to, now let's punch this into the calculator. That's the square root of 355,325 over 200 minus 38.175 squared, and this gives us 17.9, and this would be our final answer. We can conclude that therefore our mean x bar is 38.175 and our standard deviation is 17.9. Number 5, part A. Find the total number of different arrangements of the 7 letters in the word success. Alright, so that will be, since we have 7 letters, that's 7 factorial, and then the S appears 3 times, 1, 2, 3, so divide by 3 factorial, and then the C appears 2 times, so divide by 2 factorial. Let's punch this into the calculator. This is 7 factorial divided by 3 factorial times 2 factorial, and that gives us 420. Part B. Find the total number of different arrangements of the 7 letters in the word success that have a C at the beginning and a C at the end, and in which the 3 C's are not all together. Alright, so we can create an expression to find this. We can say arrangements. We can say arrangement with C's at ends and no other restrictions, minus the arrangement with C's at ends and all S's are together. All S's are together. This should simplify to give us the arrangements in which we have C's at the ends and in which the 3 S's are not all together. So let's start by finding the number of arrangements in which we have the C's at the ends and no other restrictions. So that's C, and then 1, 2, 3, 4, 5 letters in between, and then C. So the letters that remain are S, U, S, S, E. Alright, so we're just rearranging the 5 letters in between. So that would be 5 factorial divided by, we've got the S's appearing 3 times, so divided by 3 factorial. That's the first scenario where we have the C's at the ends and no other restrictions. Now let's evaluate the second scenario. So we've got the C's at the ends and then the S's are all together. So we've got a block of S's here. So that's the block of the S's, and then 2 letters will remain. That's the U and the E. Counting the underlines, we are rearranging 1, 2, 3 items. So 3 factorial. So it means we've got 5 factorial over 3 factorial minus 3 factorial. Let's punch that into the calculator. 5 factorial over 3 factorial minus 3 factorial, and that gives us 14. Alright, and that's our final answer. 4 letters are selected at random from the 7 letters of the word success. Part C. Find the probability that the selection contains at least one S and at least one C. Alright, so let's write down all the different scenarios we can have. So we've got one S and one C. We could have one S and two C's. We could also have two S's and one C. We could also have two S's and two C's. And then finally, we could also have three S's and one C. Alright, so now let's evaluate each scenario. So for the first scenario, we're saying that we've got 4 slots, 1, 2, 3, 4, since we're selecting 4 letters. And we've reserved 1 slot for an S and 1 slot for a C, and then the rest are for the remaining letters. So this scenario here would be, we've got a total of 3 S's, but we only want one of them. So that's 3, choose 1. And then we've got a total of 2 C's, but we're only selecting one of them. So that's 2, choose 1. And then the remaining letters that are neither an S or a C are U and an E. So there are 2 slots that they can go into. So that's 2, choose 2. Alright, if we punch that into the calculator, that would be 3 times 2 times 1. So that's 6. And then let's evaluate the second scenario. We've got an S and 2 C's. So here we're picking one S from 3 S's, so that's 3, choose 1. Then here we're picking 2 C's from 2 C's, so that's 2, choose 2. And then finally we've got 1 slot for the remaining 2 letters, so that's 2, choose 1. So this would be 3 times 1 times 2, which is 6. And then we've got, in this third scenario, we've got 4 slots. 2 of them are reserved for the S's, and then we've got 1 for the C. So we're picking 2 S's from 3, so 3, choose 2. And then we're picking 1 C from 2, so 2, choose 1. And then finally we're picking only one of the other remaining 2 letters, so 2, choose 1. This will be 3 times 2 times 2, so that's 12. And then on our fourth scenario, we've got 4 slots, and 2 of them are reserved for 2 S's, the other 2 are for the C's. So that means we're picking 2 S's from 3, so 3, choose 2. We're picking 2 C's from 2, so 2, choose 2. And then there are 0 slots for the remaining 2 letters, so 2, choose 0. And if we simplify this, this becomes 3 times 1 times 1, so that's 3. And then we've got our final scenario where we've got 3 S's, 1, 2, 3, and 1 C. So we're picking 3 S's from 3 S's, so 3, choose 3. We're picking 1 C from 2 C's, 2, choose 1. And then we've got 0 slots available for the 2 remaining letters. So 2, choose 0. So this simplifies to 1 times 2 times 1, which is 2. And so let's tally up all the scenarios. This is 6 plus 12 plus 3 plus 2. So the total here would be 6 plus 6, 12 plus 12, 24 plus 3, 27 plus 2, 29. Okay. And notice that what we're actually looking for is the probability. We've just evaluated the number of different selections in which we've got at least one S and at least one C. So for us to find the probability, we can create an expression saying that this would be number of selections in which we have at least one S and at least one C, right? And then this would be divided by the total number of selections with no restrictions. Total number of selections. Alright. So our probability would be, we say that when we have we say that the total number of selections in which we have at least one S and at least one C are 29. And then the total number of selections where there are no restrictions would be 7, choose 4, since we've got 4 slots and we're choosing from a total of 7 letters. Alright, so our probability here would be 29 over, let's punch 7, choose 4 into the calculator, that is 35. So 29 over 35, we can leave it like this, or we can give it to 3 decimal places, which would be 0.829, 0.829, and this here would be our final answer. Number 6. The weights of adult cars of a particular breed are normally distributed with mean 4.5 kgs and a standard deviation of 0.8 kgs. Part A. Find the probability that a randomly chosen adult kit of this breed has weight between 4.1 centimeters and 5.1 centimeters. Alright, so let's define our random variable. Let W be the random variable. Weight in kg of adult kit. Alright, so W follows a normal distribution with mean 4.5 and variance 0.8 squared. Okay, and we want to find the probability that this weight is between 4.1 and 5.1. So probability that our weight is between 4.1 and 5.1. Let's standardize. This is the probability that's 4.1 minus 4.5 divided by our standard deviation, which is 0.8. And then we've got 5.1 minus 4.5 over 0.8. So let's simplify this. We've got 4.1 minus 4.5 over 0.8, and this gives us negative 0.5. And then we've got 5.1 minus 4.5 over 0.8, and this gives us 0.75. So if we sketch a bell curve of our problem, we've got this here would be 0, and then we've got negative 0.5. Let's put that somewhere here. And then we've got 0.75, 0.75, and we're looking for this area over here. We can find that area by saying phi of 0.75 minus 1 minus phi of 0.5. Alright, so let's read off phi of 0.75 from our normal distribution tables. That gives us 0.7734 minus 1 minus phi of 0.5, which is 0.6915. Alright, so let's simplify this. This is 0.7734 minus 1 minus 0.6915, and this gives us 0.4649. So we can conclude that therefore the final answer is 0.465. The weights of kittens of this breed also have a normal distribution. A scientist examines the weights of a random sample of 150 kittens of this breed. He finds that 36 have weights less than 1.46 centimeters and 15 have weights more than 3.54 centimeters. Part B. Find the estimates for the mean and standard deviation of the lengths of kittens of this breed. Alright, so let's define our random variable. Let K be the random variable. Weights in this should be kgs, not centimeters. In kgs, weights in kgs of kittens. Alright, and this follows a normal distribution with mean mu, and our variance is sigma squared. We have to find both mu and sigma. We've been given that 36 of these kittens weigh less than 1.46. So the probability that K is less than 1.46 kgs is equal to 36 out of a total of 150 kittens. Then we've also been given that 15 weigh more than 3.5, so K is greater than 3.54 is equal to 15 out of 150. So this is the probability that K is less than 1.46 is equal to, let's punch 36 over 150 into the calculator. That gives us 0.24, and then we can evaluate K is greater than 3.54, and that gives us 15 over 150. That gives us 0.1. Alright, so if we standardize, this here would be the probability that Z is less than 1.46 minus mu over sigma, and it's still equal to the 0.24. I'll just replace this part with Z1 so that it's easier to read. Z1 is equal to 0.24. You can sketch a bell curve for our problem here. So this is 0, and we're looking for 24% of the area on the less than side, so that should be somewhere over here. So we can tell from our diagram that our Z1 is going to be negative, because this area over here is 0.24, and that other area would be 1 minus 0.24. 1 minus 0.24, that is 0.76. 0.76. We can find Z1 by saying, we know that Z1 is going to be negative. We can find it by saying arc phi of our probability here, or our area, 0.76, and we can read off the value of arc phi of 0.76 from our normal distribution tables, and this gives us 0.707. So Z1 is equal to negative 0.707. Alright, and remember we said at the beginning we replaced this expression over here with Z1. So we can say that Z1 is equal to that expression, which is 1.46 minus mu over sigma. So that's negative 0.707 is equal to 1.46 minus mu over sigma. Alright, and we're going to do the same for our other problem here. So we start by standardizing. This is Z is greater than 3.54 minus mu over sigma, and this is equal to 0.1. We're going to replace this expression with Z2. So the probability that Z is greater than Z2 is equal to 0.1. And we're going to sketch a bell curve. So here's our bell curve. This here would be 0. And we're looking for 10% on the greater than side. So 10% would be somewhere here. This is Z2. From our diagram, we can tell that Z2 is going to be positive. This area is 0.1. The unshaded area is 1 minus 0.1. That's 0.9. So we can use the larger area to find our Z2. So Z2 is equal to arc phi of 0.9. So find the corresponding Z value for an area of 0.9 in the normal distribution tables. And that would be 1.282. And like we did earlier, we said Z2 is equal to the expression that we have over here. So Z2 is equal to 3.54 minus mu over sigma. Alright, so let's substitute Z2 with 1.282. So 1.282 is equal to 3.54 minus mu over sigma. Let's make this linear. So 1.282 sigma is equal to, that's 3.54 minus mu, and I'm just going to make mu the subject of the formula in this one. So mu is equal to, that's 3.54 minus 1.282 sigma. And going back to our other equation, I just want to make it linear as well. So that would be negative 0.707 sigma, and this is equal to 1.46 minus mu. Alright, we've run out of space. Let's just write our two equations on the side. I'm going to do that in red. So we've got that's negative 0.707 sigma is equal to 1.46 minus mu, and then we also have mu is equal to 3.54 minus 1.282 sigma. Let's substitute mu here with 3.54 minus 1.282 sigma. So negative 0.707 sigma is equal to 1.46 minus 3.54 minus 1.282 sigma. Alright, so let's simplify. Negative 0.707 sigma is equal to 1.46 minus 3.54 plus 1.282 sigma. So that's negative 0.707 sigma is equal to, we have 1.46 minus 3.54, and that gives us negative 2.08 plus 1.282 sigma. Let's make sigma the subject of the formula. So that's 1.282 sigma plus 0.707 sigma is equal to 2.08. Let's simplify our left hand side. 1.282 plus 0.707, that gives us 1.989. Sigma is equal to 2.08. Divide both sides by 1.989, and sigma is equal to 2.08 over 1.989, and this gives us 1.04575164. Alright, the reason I've taken the calculator display is because we want to substitute it into this equation over here so we can evaluate mu. So sigma is 1.04575164. If you don't want to use the full calculator display, just use to about 4 decimal places and you should be fine. So that's 3.54 minus 1.282 times 1.04575164, and this gives us 2. Now I'm not going to use this value further, so I'm just going to give it to 3 significant figures, which is 2.20. So we could conclude that mu, therefore mu is equal to 2.20 and sigma is equal to 1.05, and this is our final answer, and that is also the paper. Okay, so I hope you guys found this video useful, and if you did, please leave a like and consider subscribing for more videos like this. Otherwise, I wish you the very best in your Stats 1 exam. Good luck.